Hi, my name is Meeta Kumar. In this module, we continue our discussion of consumer theory, focusing particularly on indifference curve analysis. Recall that consumer theory analyzes decisions made by consumers regarding what goods to buy and in what quantities to buy them. What a consumer buys depends on two things. One, what does the consumer want? And two, what can the consumer afford to buy? In this module, we examine the first question again. How does the consumer decide what to buy and how much of it to buy? In the last module, we discussed how Marshallian utility theory deals with this question. We saw how a severe limitation of the Marshallian approach is the assumption that satisfaction can be measured. The problem is that we cannot really measure satisfaction, particularly, for example, we can't measure the satisfaction we are getting from eating a pizza or a mango or a banana. If utility cannot be measured, it would be difficult to give it a unit like a util. So, measuring total utility and marginal utility becomes very difficult. Now, while we cannot measure utility, what we can do is to rank goods in terms of the satisfaction they give us. So, it's possible for me to say that I like mangoes more than bananas, or even more specifically, I could say that I like 2 mangoes as much as I like 3 bananas. Such an approach allows me to rank commodities or even bundles of commodities in order in which I like them, without having to measure the utility of any individual commodity. We use this concept when we are trying to analyze how consumers decide what to buy. Since we are dealing with rankings or orderings of bundles, this approach is called the ordinal approach to utility. We shall study the indifference curve theory as an example of one such approach. In this module, we start with the description of what makes me prefer one bundle of commodities over the other. We keep the Marshallian assumption that consumers consume because commodities give them utility. What we reject is the idea that this utility can be measured. In fact, we don't need to measure utility to analyze consumers' behavior. All that we need to figure out is this. Given a set of available bundles, which one would a consumer choose? And the answer is simple. The consumer will choose the bundle that gives her the maximum utility. How do we know which bundle gives the consumer the most utility? We ask the consumer to rank all the available bundles in order of preference. Let us go back to the bundles of movies and books we were examining in the module on the budget constraints. Think about these bundles showing up on your virtual screen. Bundle A contains 8 movies and 12 books. Bundle B contains 8 movies and 24 books. Bundle C has 16 movies, 16 books, and Bundle D has 24 movies, 24 books. How would Bundle A compare to Bundle B? Bundle B has more books and the same number of movies as Bundle A. Naturally, I choose Bundle B over Bundle A. Can you say which one of these bundles a consumer would like the best? Clearly, this would be Bundle D, because Bundle D has more books and more movies than any other bundle. Which is the least preferred bundle? Clearly, this is Bundle A, because it has the least number of movies and the least number of books in all the 4 bundles listed. Now, how would I compare Bundle B and Bundle C? I have more movies in Bundle C, but fewer books. These bundles are actually more difficult to rank outright. If I like books a lot, more than movies anyway, then I will prefer bundle B to bundle C. If I prefer movies more, then I may prefer bundle C to bundle B. If I were told to order these bundles in the increasing order of my preferences, here is how I would rank them. Bundle A is less than bundle C, is less than bundle B, is less than bundle D. In other words, I like bundle A the least and bundle D the best. And I prefer bundle C to bundle B. On the other hand, you may draw up the following ranking in increasing order of preferences. Bundle A is the worst, bundle B is better, followed by bundle C and then bundle D. In other words, you also like bundle A the least and bundle D the best. However, you prefer bundle C to bundle B. Similarly, your friend may draw up an alternative ranking in which she likes bundle A the least, she likes bundle B as much as she likes bundle C, and she likes bundle B and C both less than she likes bundle D. Indifference curve theory uses these intuitive ideas to analyze a consumer's preferences. It assumes the following about the preferences of the consumers. 1. An individual is able to rank all bundles in order of preference. Economists often state this as preferences are complete. So, I may like some bundles more than others and some bundles as much as others, but I can always draw up a complete ranking. An individual always prefers more to less. So, any bundle which has more of at least one commodity is preferred to the one that has less. Notice that in the examples that we took, all of us liked bundle A the least and bundle D the most. Why? Because bundle A has the least number of movies and books among all the bundles, and bundle D has the most number of movies and books. The underlying idea is that if I consume more of a commodity, my utility from that commodity always goes up. So, my total utility from consuming a bundle with more of any commodity and no less of the others is always greater. And I will always prefer a bundle that gives me more utility to a bundle that gives me less. Here, there are two underlying but related assumptions. A. Consumers always prefer more to less. This is called rationality of the consumer. Why would you want less if you can have more in any case? B. The second assumption is that consuming more gives me more utility. In other words, utility always increases when consumption increases. Consumers who prefer bundles with more of any commodity and no less of the other are said to be having monotonic preferences. Consumers are consistent, and that's the third assumption that we make. In other words, a consumer that has ranked one bundle over the other will always prefer the first bundle to the second one. She will not switch preferences. A consumer is said to be indifferent between bundles if she prefers them equally. In the example that we discussed above, your best friend likes bundle B as much as she likes bundle C. She is said to be indifferent between the two bundles. Indifference between two bundles implies that they both give her the same utility. So, your friend derives as much utility from bundle B which contains 8 movies and 24 books, as she does from bundle C, which contains 16 movies and 16 books. Notice what has changed between the two bundles, C and D, is the number of books and movies that each has. Bundle C has 8 more books, but it also has 8 less movies. In other words, your friend is able to substitute movies for books. How many books your friends would need in order to compensate her for giving up each movie is called the rate of substitution. In this case, the rate of substitution, notice, is 1 for your friend. Your friend is giving up 1 movie for 1 book. Typically, economists are concerned with what the rate of substitution is at the margin. That is, when the consumption of one commodity changes by a very small amount, how much of the other commodity is needed to keep the total utility of the bundle unchanged. This is usually called the marginal rate of substitution. The marginal rate of substitution is defined as the change in number of books divided by the change in the number of movies. Now, how can we represent these preferences diagrammatically? Consider the diagram on your virtual screen. We have represented movies on the x-axis and books on the y-axis. Various points on this diagram, such as A, B, and D, represent bundles of movies and books. What can we say about the points A, B, and D? Clearly, A has less of both movies and books than B, whereas D has more of both. A consumer would therefore derive greater utility from a bundle like B than from A, and she would derive even more utility from the bundle D than she would from B. So, the consumer would clearly prefer B to A and D to B. But what about a bundle like C? At C, the consumer has more movies than in bundle B, but she has less books. Is it possible that the consumer is indifferent between B and C? If that is the case, then B and C are said to lie on the same indifference curve. Indifference curves plot all the bundles that give a consumer equal utility. The curve in your diagram U1 represents one such curve. There would be similar curves passing through points A and through point D as well. In fact, complete preferences mean that every bundle in this diagram must lie on some indifference curve. The set of indifference curves representing a consumer's preferences is called an indifference map. The diagram on your virtual screen represents one such indifference map. What can we say about the shape of indifference curves? 1. Indifference curves are downward sloping. It is easy to see why this is so. If my utility is to stay constant, which by definition it must along an indifference curve, then as I increase my consumption of movies, my consumption of books has to go down. If it doesn't, my total utility will increase and I will not be on the same indifference curve. 2. The farther away the indifference curve is from the origin, the higher the level of utility it represents. Again, as I move further from the origin, the amounts of both goods in each bundle are likely to increase. In my diagram, this can be seen as we move from the point A to B to D. The indifference curve passing through A will then represent a smaller utility than the one passing through B. The indifference curve that passes through D will represent a still higher level of utility. The third feature of indifference curves is that indifference curves are convex to the origin. Now, this is a little less obvious. Consider the indifference curve on your screen. At point A, I am consuming 5 movies and 16 books. If I move to point B, I can consume 10 movies and 10 books with the same amount of total utility. And this is important. The total utility hasn't changed. I have given up 6 books to get 5 more movies. My rate of substitution from A to B therefore is 6 divided by 5, which equals 1.2. If I now move from B to C, once again my total utility remains unchanged because I am on the same indifference curve, but I am now consuming 15 movies and 7 books. I have only given up 3 books for 5 movies. My rate of substitution from B to C is 3 divided by 6, which is 0.5. Notice that this rate of substitution has fallen as I have moved along the indifference curve. The boat shape of the indifference curve reflects this behavior. It reflects the fact that preferences typically follow a diminishing rate of substitution along the indifference curve. The intuitive reason for this diminishing rate of substitution is based on the notion of diminishing marginal utility. As I consume more and more of one commodity, in this case movies, I derive progressively less and less satisfaction from every additional movie that I consume. So, I need to give up fewer and fewer units of the other commodity, in this case books, to keep my total utility constant. Also, as the number of books I have goes down, each book on the margin gives me more utility, right? So, I have to give up fewer books for each extra movie that I consume. This also leads us to 2 very important properties of indifference curves. One, the slope of the indifference curve is the marginal rate of substitution between the commodities on the axes. The marginal rate of substitution is the ratio of the marginal utility of the commodity on the x-axis to the marginal utility of the commodity on the y-axis. In my example above, the marginal rate of substitution of the indifference curve at A is the following ratio. It is the marginal utility of movies divided by the marginal utility of books. In general, for any 2 commodities, X and Y, we can define the marginal rate of substitution as follows, as is shown on your screen. Indifference curves can never cross, and this is the 4th characteristic of indifference curves. Consider what happens if 2 indifference curves on the same map were to cross each other. This is represented on the diagram on your screen, where U1 and U2 are indifference curves from the same map that cross each other. Here, since both points C and B are on the same indifference curve U1, the consumer must be indifferent between them. Similarly, since point A and B both lie on the indifference curve U2, the consumer must be indifferent between them as well. Now, this implies that the consumer must be indifferent between A and C as well. But C clearly has more of both movies and books. So the consumer cannot be different between A and C. To do so would make the consumer irrational. Remember, monotonic preferences and rationality mean that more is always preferred to less. So A and C cannot lie on the same indifference curve, and hence indifference curves cannot possibly cross each other. We can now put together what we've learned about budget sets and indifference curves to figure out what the consumer consumes and in what quantities. The diagram on your screen reproduces the budget set discussed in the earlier module. The budget set represents what the consumer can afford to buy given a certain income, in this case 2,000 rupees, given the prices of commodities, in this case 50 rupees a movie and 100 rupees a book. Superimposed on this budget set is a consumer's indifference map. This represents the consumer's preferences. The consumer will try to achieve the highest level of satisfaction that he can achieve given his budget, given the prices of the commodities, and given his preferences. Notice that the highest possible indifference curve that the consumer can reach is the one that just touches or is tangent to the budget line. This occurs at point E on the diagram on your screen, where the consumer is consuming 16 movies and 12 books. This is called the consumer's equilibrium. At E, the consumer's utility is maximum, given his income, given the prices of the movies and the books, and given his preferences. The consumer can do no better than this and has no incentive to change unless prices change or his income changes. At E, the slope of the budget line equals the slope of the indifference curve. Recall that the slope of the budget line is the ratio of the prices of the commodity on the x-axis to that on the y-axis. And the slope of the indifference curve is the marginal rate of substitution. This gives us the equilibrium condition, that is, marginal rate of substitution between x and y will equal the ratio of prices px divided by py. In our example, the marginal rate of substitution of movies for books equals the price of movies divided by the price of books. So this is rupees 50 divided by rupees 100 equals half. What we have done is we have answered the questions we had raised at the beginning of this module. What does the consumer buy? Our consumer buys books and movies. In what quantities does he buy them? He buys 16 movies and 12 books. We are restricted to 2 commodities because we are working with 2-dimensional diagrams. In principle, we can extend this analysis to many more commodities. What happens if the price of movies changes? Suppose the price of movies goes up to 100. We saw in the previous module how the budget line changes now. This is depicted on your diagram in the virtual screen. Superimposed on the new budget line then is the consumer's indifference map once again. The consumer's old equilibrium, E1, is now beyond his new budget line, which is green in color. He cannot afford it anymore. His new equilibrium, where his new budget line is tangent to the highest indifference curve that he can reach, and this is at E2. He now consumes only 10 movies and 10 books rather than 16 and 12. Notice that the number of movies consumed has gone down as the price of movies has gone up. This forms the basis of the theory of demand that you will study in subsequent modules. Let us now summarize what we have discussed in this module. We have studied how to depict consumers' preferences through indifference curves. We have also learned how indifference curves and budget lines can be combined to derive the consumer's equilibrium. In a subsequent module, we will use these concepts to explore the theory of demand. Thank you.